Okay, so this set of notes is about acids, bases, and salts, mostly about acids and bases. You need to know the difference between acid and base and discuss their properties. I need to be able to convert the hydrogen ion concentration into a pH value. So you need to know what pH means, and you don't have to do a lot of calculations. Don't worry about that. You also need to understand what buffers do, because they're very, very important to our body, and then how we get salts from acids and bases, and it's pretty simple stuff. So water we know is H2O, but sometimes we write the structural formula. If you remember from the last set of notes, this is the structural formula right here, right? So we know that each oxygen has a hydrogen bonded to it, like this, so that we know that it's not something like this. It's not H bonded to H bonded to O, right? We know that doesn't happen. So this is the structure of it, and it shows that when you break it apart, you actually get two ions. You get an H plus ion, which is a hydrogen ion. That's the cation. And you get the hydroxide ion, or the OH negative, which is the anion. So remember that positive ones are cations and negative ones are anions. Now, in water, when it breaks apart like this, there's exactly the same amount of H pluses as there is OH minuses. So it's equal. So the concentrations of hydrogen ions, which are the H pluses, and hydroxide ions are the same. And that means that it's neutral. It's neither an acid nor a base. What an acid is when something is dissociating like that. Remember that was dissociation. We talked about it in class. I forgot to mention it right there. But that's called dissociation when it breaks apart into its cation and its anion. Now, if it's an acid, what happens is it has a lot more of these H pluses get made. Right? So if there's lots and lots of H pluses made, it becomes an acid. The converse of that is that if there's lots and lots of these OH minuses made, then it's a base. So these are acids, and this is base. Like I said in class, you don't need to worry about the whole proton donor and acceptor thing. It's something we're going to do when you get to chemistry. But basic, it is really important to know what an H plus is, though. H plus, hydrogen ion. Now remember, hydrogen is atomic number 1, so it has one proton in the middle, and it has one electron out here cruising around it. Right? We have one electron. Well, to become a positive ion, or a cation, we need to lose this electron. So if that electron goes away, all that's left is that positive proton. So this is really just a proton. H plus is just a proton. It's just crazy that it is, but it's what it is. Now, some bases don't make hydroxide ions right away, but they do. So like ammonia is a really strong base that we need to recognize as a base, even though it doesn't have any OHs in it. In fact, it has H's, which looks like, hey, that's probably an acid. But it's not. When it reacts, it actually ends up indirectly making lots more OH, or hydroxide ions, so it ends up being a base. Now, how we decide how acidic something is we give it a term called a pH, and that's a scale from 0 to 14. Now, the way they got this is using a logarithm, which has to do with the exponent. So this number right here would be written as 10 to the negative 7. This exponent, this log function thing right here in your calculator, tells you what this exponent is. So in this case, it's negative 7. Well, the log is the negative of that. So the pH is the negative log. Well, if the log is negative 7, then the pH has to be positive 7. Right? And that's for pure water. So that if the pH is exactly 7, that's pure water. That means the concentration, remember we said the little brackets mean concentration, is equal to the concentration of hydroxide ions. So if it's pH 7, then there's equal concentrations of hydrogen ions and hydroxide ions. Sorry about that. If it's an acid, remember we said an acid is a thing that makes a lot of H pluses. So that means there's a lot more H pluses than there are OH minuses, or hydroxide ions. And that means the pH is less than 7. Anything less than 7. 6.9 is less than 7. So it's still an acid, but it's a very, very, very weak acid. Basic solutions are when there's more OH negatives, or hydroxide ions, than there are hydrogen ions, right? So there's more of those. That means the pH is above 7, and it's called a base. Base, or it's something that's called basic. Now, we have buffers in our body that kind of help control our pH of our body and our blood. And remember, that is called homeostasis, or a homeostatic mechanism. Homeostasis. This is something that you're going to be reminded of over and over again in this class. Homeostasis is the system, your body kind of balancing stuff out. In this case, it's the pH of our blood at about 7.4, and it does that by using things called buffers, which it's a system. It's a acid and a base, but it's a very weak acid and a very weak base that's put together. The important part for you to remember is that a buffer is something that resists change in pH when an acid or a base is added to it. That's the important part for you guys. How it works in our body. This is the equation. We use CO2. If all of a sudden we start adding a whole bunch of hydrogen ions, if we get a whole bunch of hydrogen ions right here, if this increases, it's like a bucket. Remember I said like the bucket? If it fills up, it's going to overflow and go this way. Well, it makes the whole reaction go this way. Right? And it balances it out. It causes it to be more basic. If we add, well, it doesn't make it basic. It's still a little bit acidic if we have a bunch of H pluses. But it reduces the effect of adding a bunch of H pluses. Same with the other way. If for some reason you have a whole bunch of hydroxide ions, OHs, it's going to force the reaction to go that way, produce more H pluses, and kind of neutralize it or balance it out. When we do neutralize or mix an acid and a base, we end up with a salt. Where does it say salt? There's salt. We end up with a salt. The classic one we always see is this one. This should be H2O. I don't know why this did it again. That's bad. There, watch this. This is kind of cool, huh? So H2O plus NaCl. You can see the H from the hydrochloric acid goes with the OH from the sodium hydroxide to make the H2O. The chlorine and the sodium get together to make salt. So you mix an acid and a base and you get salt and water. Easy stuff. Salts are very, very important in systems, in animals, and in plants. They help maintain our homeostasis. It's also what helps conduct electricity. Remember we talked about when you're standing in water, that's the stuff that actually conducts electricity and electrocutes you. So you just need to know it's important, and we need it. That's it. Right? The things are acids have hydrogen ions, bases are hydrogen ion acceptors, or make, this is, I don't like the way this is written, bases give us hydroxide ions, right? Acids give us hydrogen ions, and the pH scale goes from 0 all the way to 14, with 7 being neutral water in the middle. This is bases over here, and this is acids over here. All right, good, easy stuff.